Okay, sorry about that. We're continuing with the discussion. We're talking about density. I talked about Archimedes, but I'm filming this with my phone, and I got a phone call, and that stopped the video. So I'm continuing. So we're going to consider lead. So you have to go back to density 1, that's the one before this. Take 1 cubic centimetre of, lead. Chemical symbol is Pb. Plumbum. Plumb line. Lead line for measuring how vertical things are. Plumber. Pipes were made of lead one time. Plumbers. Word plumb comes into all sorts of different things. The Latin word for lead is plumbum, so we write down Pb as a symbol for lead. So we're going to take 1 cubic centimetre of lead. And we're going to take this piece we're going to weigh it. Put it on the weighing scales, balance, any way you want to do it. And I'll have to put 11.2 grams of weights over here to balance it. We find that for lead, it's not 1 gram, it's 11.2 grams. How many times heavier than that per gram is it than water? 11.2 times heavier than water, right? So, what's the mass of 2 cubic centimeters of lead? .4 grams. What's the mass of 10 cubic centimeters of lead? The answer is 10 times 11.2, or 112 grams. This is what we're doing for lead. Now, suppose you're told the following. we're going to be given a bunch of densities of different substances. For example, aluminium is 270, iron is 786, get used to the chemical symbols. Aluminium, iron, gold. What else can we get to? Mercury is a very interesting one. Mercury is a heavy metal which is not a rock group. Could be. Actually, it's a good name for a rock group. Mercury, heavy metal, right? 13.6 grams is the mass of every single cubic centimetre of mercury. When I was a kid, I used to hold it in my hand. Didn't seem to do me any harm. Suppose we're given a list of densities. Let's say a list of 100, well, there isn't. There are only, for pure elements, there are less than 92 naturally occurring metals on the earth, which are metals. So let's say 75 elements which are metals, right? We're given that list. Let's add lead to it. So we have a list and we can refer to this, okay? Now we want to find out, I'm leading up to another Archimedes story, by the way. That's what's happening here. We want to find out what metal is this stuff that we have? Okay, here's what we do. Find out 2 things about the metal. Now we're told what its volume is, 40 cubic centimetres. Somebody went and found that. There are ways to find that, and I'll tell you about that in a minute. We'll talk about that in a minute. But somebody went away and found the volume. How do we find its mass? Well, that's simple. We put it in a balance that can move this thing across. We put the thing in the air. We find its mass. Okay. Oh, somebody's done it already. Okay, we could have gone away and done this. I didn't notice that I'd already given you the mass. So, the density of this is found by finding the mass of 1 cubic centimetre. We know what the mass of 40 is, right? The mass of 40 kids was 40 pounds. What's the mass of each kid? 1 pound. The mass of 40 kids was 400 pounds. What's the mass of each kid? 10 pounds, right? That's the way you do it. So what we got is density mass divided by volume is the mass of 1 cubic centimetre. This is fine to be the density. So, it's going to be 448 over 40. So we divide. And this goes once. So take the 40 from the 44 and bring down the 8. 40 in the second one goes once. And left with 8. 40 into 80 goes twice. What do I get? 11.2. 11.2 what? These are the units. They are the units of density. Now we're going to check our list to see which one is it. Is it aluminium? This is 2.7, sorry. This is 7.86. And this is 19.2. I made a mistake. I sometimes do that, okay? So we go through a list. Is it aluminium? No. This is only 2.7 grams for every cubic centimetre. This is only approximately 8 grams iron for every cubic centimetre. And now 19.2 grams for every cubic centimetre is more than this. Gold. Gold is heavy. Incidentally, uranium, which is element number 92, also has a density close to that, about 19.1 actually. And plutonium, about 19.9. Strangely, they're all less than, let's put another one on them. Platinum. Has a density of approximately 21.3. So that's on the list. Let's see. Oh, wait a minute. There's 11.2 down there, right? So down here we see that this is very close. This is what we've got here. Now, we can identify the metal most likely as being lead. Okay? There may be another metal with that same density, but there could be an alloy. We could set up an alloy by mixing, let's say, iron and gold in certain proportions to achieve a density of 11.2. Yeah? Well, that's what the king at one time thought that this guy did when he made a golden crown. Now, this golden crown came along and the king didn't know, I don't think this is the real gold. I wonder if it is or not. It feels a bit light. So what did he do? He sent the job off to Archimedes. Archimedes did jobs like this. The king sent the job to Archimedes. He wanted to find out if the crown was made out of gold that was pure, or maybe there's some lead mixed in there. What's Archimedes going to do? Well, Archimedes, clever guy as he is, he needs to find the density of the crown. So, wait a minute, how are we going to find the volume of this? If I had an even volumed, let's say a regular, rectangularly shaped piece of metal, I can find its volume by measuring the sides and going length times width times height. In this case here, I get 3 3s is 9, 2 9s 18. But what about this one here? Archimedes had a problem. How am I going to find the volume of this guy? Well, he thought it out. So one day, Archimedes was working on this problem, and he filled a bath absolutely to the top, right? Full of water. He hops in. When he hops into the water, what happens to the water? It comes up over the edge. The water flows out. And the amount of water that flows out is going to be the volume of Archimedes. We want to find the volume of an irregularly shaped stone, but we can't really measure it. Well, we can't measure it with a ruler, but we can take it like this. Okay, so we make sure that the level of water comes right up to this spout. And then we drop the stone in. The stone displaces a certain amount of water which flows in here. Now the volume of the displaced water we can catch in a measuring cylinder. It's actually called a graduated cylinder. And we can read off the volume of the stone very nicely. So, what did Archimedes do? Find the volume by displacement. So let's see how we can do something like that. In the laboratory at home, anything like that, somebody gives you a stone and they say, find the density of this stone. Suppose we go away and weigh the stone, and we find that its mass is 60 grams. Now we don't have to use a displacement can. We can take a graduated cylinder. We can take a graduated cylinder with water in it, but that the stone can fit. Now, we take the stone, and then we lower it into the graduated cylinder. Now, what happens to the water? I didn't lower it yet. When the water is lowered into the stone, when the stone is lowered into the water, the level of the water rises, goes up. It goes up by the water displaces its own volume. The volume of the stone is the same as the volume of the displaced water. It's like if we took this much water over here. That ball of H2O is going to have the same volume as the stone. In this case, it went up 20 centimeters cubed. Okay? Now we want to find the mass of 1 cubic centimetre. We know the mass of 20. What do? Well, we'll have a formula from now on. I haven't used it before because I wanted you to think things through. In this case here, 60 divided by 20 is 3 grams per cubic centimetre. So this particular stone, the substance in it, whatever it is, could be calcium carbonate, I don't know. Calcium carbonate is limestone, chalk or marble, but it has each one has a different density. Suppose it's limestone. 3 grams is the weight of every single cubic centimetre of this stuff. Question. I don't know what the density of limestone. I'm just going to say it's limestone. And this time I'm putting in the units to show you the way you cancel them during the calculations. We go the mass of 1 cubic centimetre, times 20, because we have 20 cubic centimetres to find its mass. 3 times 20 is 60. We like to be neat with our units from now on, and we'll go cubic centimetres cancel cubic centimetres, and we're left with grams. Okay? So, what have we learned? Let's summarise. Well, we learned a lot of things. Okay, so Archimedes found the density of the crown. I can't remember for sure if it was real gold or not. But he did do something. When he got into the bath, he had no clothes on. He was very happy when he figured out how to do the job for the king, because he's going to get paid for it. So he went down the street saying, Eureka. discovered. Okay, to summarize, mass of unit volume is density. And we use cubic centimeters, which is 10 to the power of minus 6 cubic meters. And the unit of mass is 1 gram, or the weight of a single cubic centimeter of water. The density of water is 1 gram per cubic centimeter, but all other substances have different densities. Hg, try to remember, is the symbol for mercury. Density is 13.6 grams per cubic centimeter. Now, density is generalized then thereafter. The idea of it has a big thing, not just like what we're doing here. Find the mass of something. If it gets a little bit complicated, you go into mathematics. Density is very often an object under the integral sign. And density, right? In tensor calculus, there are certain tensor densities. That's a tensor density. Generalized in many different ways. Okay, so there are other things such as buoyancy coming up. That's Archimedes' law of flotation. I will just state it. And a body is partially or wholly immersed in a fluid, the weight of the displaced fluid is equal to the loss in weight. Now that's something we'll discuss the next day, but it leads to something interesting. Could you float the Titanic in a cup of water? We'll talk about that next day.